So as we noted in our last discussion in the standard normal curve, there's a lot of different curves, right? You could have something that looks like this. All right, here's a normal curve. Now this one might be, say, the mean is at 15 and a standard deviation might be 6. But you might also have one that looks like this, okay? You could have one that looks like this, where the mean here, what's that? Where the mean here is at 30 and a standard deviation might be 2. All right, so there's just infinitely many curves here, and we can't make a table of probabilities or program in the calculator to do all of these infinitely many. So what we're going to do is we will standardize these curves. And we will do so by using this. And we will do so using, all right, now we've seen this before, this is the z-score, using z equals x minus mu. Now we did x minus x bar, but now we're doing x minus mu over sigma. Now after we standardize, everything will fit into a table and be programmable on our calculator. So we can get an idea of what happens if we just make a little drawing here. All right, if we go to our x's, x and p of x, draw a normal curve here. All right, now that high point we know is the mean. Now if I want to standardize this, I could use this formula here. Z is equal to x, my x value, my raw score, minus the mean over sigma. Now what I'm going to use for my x value is this one right here, just to see in the standard curve, what does mu become? All right, so put mu right into here. That's our x value. So we will get mu minus mu over sigma, that's z. So z is 0 over sigma, so z turns out to be 0. All right, so in the standardized curve now this is going to be z down here, not x's anymore. In the standard curve, that high point is now 0. All right, so 50% of the area is to the left of 0, 50% is to the right. So this is the standardized curve. Standardized curve, the high point is always 0. And not only that, but there's our point of inflection. Sigma is equal to 1. All right, we won't develop that. But in the standard normal curve, the means, like back up here, we'll convert, that will become a 0, and this will become a 0. All right, so all the means, we're just going to standardize to zeros. Here's an example again. Let's convert the raw score, an x score of 60, to a standard score. All right, so we converted the mean. All the means convert to 0. But what if we have this? X is equal to 60. So I'm going to use this conversion formula, x minus mu over sigma. Now our x value, our raw score, is 60, minus the mean, 72, divided by the standard deviation, 15. Right? So I've got negative 8 over 15. So our z-score is equal to negative 0.8. All right, so if I draw a picture of this now, actually I'm going to draw two pictures. Here it is in x. So if I draw the picture in x, the mean here is at 72. Our raw score is over here at 60. Now, let's convert. So I convert using z equals x minus mu over sigma. So when I make that conversion, I get z equals negative 0.8. So the curve I've got now it converts to a standard curve. So this is z now, p of z the height point is now 0, not 72, and our z value, right, this value right here, that x value of 60, that gets converted now to this value here at negative 0.8. Can you try this one? Just give it a try and then come back and we'll do it together. All right, so let's convert. You know, I just like to draw these pictures so we get a good feel of what's going on. We're converting this score here. Right, we've got our raw score. So the high point here is what, 70, and we're over here at 85. All right, so convert. Z equals x minus mu over sigma. So z is equal to x. Now our x value is 85 minus the mean, 70, over 7. All right, so this gives us what? This is 15 over 7. So our z-score is, what do we get here? 15 divided by 7 is 2.14. I'm just going to round off. How about 2.14? All right, so what we get then is this picture here. This is in z. So we've converted from x's to z's. So the high point is 0, and now we're on the positive side. Now, we'll try to be a little bit accurate here, but look, one standard deviation takes you out to that point of inflection. So you know you're somewhere out here. Maybe I'm a little bit tight here, but it's just a picture. 2.14. I've copied the normal curve table at the back of our book here. It's a little hard to read because it's small, and every table that you have is probably going to be different, constructed differently. Here's how ours works. So if you want to find the probability that a z value is in some interval, here's how you're going to have to read it. You find the z value. Now here's how ours go. From z, here's the z values, the negatives, and then over here, right, they go up to 0, and then they start at 0, and they become positive. All right, so you even got a picture of it here. Here's a z value here, so if you got a negative z value, you'd look at this table on the left. If you compute a positive z value, you'd be at this one on the right. This may not make sense until we actually do it here. And the z values are just given to the, do it over here, are given to the ones place. Now you can find a second place over here. And then here's the area. So here's how this is going to read. If we want this here, now I'm going to draw a picture. Here's how to read our table. Suppose we're looking for this. I want the, now this is all z-scores, right? So let's just do it in z. Now, suppose we had this one right here. We had that, at one time, we had, my cat is sitting on my keyboard. Okay, we had negative 0.8. All right, now I want to find the probability that z is less than or equal to negative 0.8. All right, so I locate it here. Now, I'm looking for this. What's the probability that a randomly chosen value of z lands in that interval right there? Well, that probability is measured by finding that area. And here's how I find that area. I look at my curve. Okay, I look at the table. Now, it's a negative number, so I'm going to use this table. If it was positive, I would use this table. But look for negative 0.08. Now, it's really given to 2 decimal places. So what I've really got is this, negative 0.80. So I'm going to look at my table for negative 0.8. Okay, 0.8. There it is right there. You see it? Negative 0.80. All right, so negative 0.80. So my second decimal place is a 0, that one right there. So follow it down right there, 2119. All right, so this area out here is 0.2119. All right, so that probability is 0.2119. So there's about a 21% chance of getting a z value down in this region right here. Now, be careful. Even though that's negative, this number's positive, right? Because it's an area. It's a probability. So all these areas under the curve, they measure the probability. They're always positive. Let's try another one. Suppose that we make this conversion here. Let's see if we can get it to draw. I don't want blue. That doesn't even show up. All right, so here's our, now I'm going to go to z's. So that'll be a z, p of z. All right, I'll draw a curve. And suppose we're over here. Now that's 0, right? Everything zeroes out. So suppose we're over here at 1.92. All right, we get a z value of 1.92. Now I want to find the probability that z is greater than or equal to 1.92. So I'm trying to find the probability that a randomly chosen value of z lands out here. Well, I can do that if I just measure this area right there. Measure that area. Now, look how the table reads. The table reads not from here out to the right, but the table reads always to the left. Right? So you come from negative infinity up to your value. All right, so if I find now 1.92, so look for 1.92, look for 1.9, there's 1.9, and over to the 2 column. Here's a 0 column, here's the 1 column, here's the 2 column. So, where is it? 1.92 is right there. That area is 9726. Now that's this area here, right? Because the table reads to the left. So the area they're giving is 0.9726. But that's not what we want. So what do we want? We want this part over here. So this is just the way the table reads. So we're going to have to compute this. We're going to have 1, right? Because the total area under the curve is 1. 1 minus 0.9726. And that is 0.0274. All right, so that's about what? It's about a 3% chance that if you choose a random value of z, it will land in this interval over here. Let's try this one. What is the probability that z is less than or equal to, let's say, 2.15? All right, let's draw a picture. It's always good to draw pictures for these. It's z, p of z. Now, our point is 0. We're over here to the positives, 2.15. Now, it's just a picture. It doesn't matter where you put that, but I think it's over here someplace. Right there, there's a 1 right there. So that's 2.15. And we're looking for the probability that we are to the left of 2.15. So I want to find what's the probability of choosing a value of z and landing in this interval down here. All right? Well, that turns out to be this area right here, right? It's that area. Now look how the table reads. The table reads, I'm at positive, so the table reads from negative infinity right up to that number. And that's exactly what we have, right? Our picture matches that exactly. So when I find that area, I've got the probability. So go over to 2.1, and over to the 5 column. There's a 0, 1, 2, 3, 4, 5, right? Did I get it? Yeah, 5. All right, 2.15 is right there. And I'm seeing that to be 0.9842, it looks like. Hard to read. So this is 0.9842. All right, so the probability then that z is less than or equal to 2.15 is 0.9842. Got it. So that's about what? 98% of the time, z values will be in that interval. Let's try this one. What's the probability that z lands in this interval right here? Where are we? We're at 0 to 1.84. Now maybe that's over there. 1.84. So what's the probability that we land in that interval? So let's do this. Let's find that area. Now we have to be careful. How's the table read? The table reads all the way from negative infinity all the way over here. So if we find this area, let's do it. 1.84. What do we get? 1.8 over to 4. 0, 1, 2, 3, 4. That's 3. 4. Okay. 0, 1, 2, 3, 4. I get 9671. All right. So this area right here, all of this, right, all of that is 0.9671. But I don't want all of that, right? I don't want this part right here. I don't want that area. Well, that's half of it. So why don't I subtract 0.5? All right, so we're going to subtract 0.5. And we get 0.4671. Okay, that's what we're looking for. So that probability turns out to be 0.4671. All right, so sometimes because of the way the table is drawn, we have to make some adjustments. Let's try this one here. What's the probability that a randomly chosen value of z lands between negative 0.68 and 0? Right, so we're asking, what's the probability that that z lands somewhere in there? Right, what's the probability that you just randomly choose something and get a z value between negative 0.68 and 0? All right, well, we know that's going to, probability is going to be measured by that area right there. All right, so how are we going to get that? Now look how the table reads. We're over here at the negatives. I got the negatives. But the table reads, right, from negative infinity up to a number. So we're going to go from negative infinity up to this number, but that doesn't get us what we want, right? So how about if we did this? What if we took all of this, all of up to 0, which is 0.5, right? So we'll take the 0.5 and let's subtract off this part right here. And how can we get that? That we can look up in the table. So here's the plan. We're going to take 0.5 and we're going to subtract. Now, look up this area. 0.68. So look for 0.6. There it is, negative 0.6 over to the 8 column. I think that's the 8 column. Did I get it? Yeah. All right, so negative 6.8 is 0.2483. So 0.2483. All right, so that area right there, that's the 0.2483. So I can get the area that I want, this area right here, by taking half of it, that half, 0.5, and subtracting off the stuff we don't want. So let's just do it. Let's finish it off. All right, 10 minus 3 is a 7. 9 minus 8 is a 1. 9 minus 4 is 5. 4 is 2. Okay, there we are. All right, so that probability turns out to be 0.2517. So about a 25% chance we'll get a z-value in that interval. Here's another one. Let's find the probability that a randomly chosen value of z lies between negative 0.46 and 2.21. So if I draw those, maybe the negative 0.46 is over here and the 2.21 is over here. And we want to find the probability of landing in that interval right there. So I know how to do this. This is going to be this area above that interval under the curve. So I'm looking for this. All right, so how are we going to make our table work for us? You know what? I think what we're going to have to do is, because the table reads from 0, negative infinity, out to the right, what if we did this? Let's find the area, all of that area, and then subtract that area. All right, so let's go out to 2.21. All right, so first of all, let's go get this one. 2.2 to the 1 column. There's a 0 and a 1. Looks like 9864. So I'm thinking this is going to be 0.9864. All right, and then I have to add this area over here. No. What do? I've got 9864. What is that? That's from here all the way out, right? That's all the way out. So all I have to do is subtract this area. Subtract that. So let's go to 0.46. All right, so 0.46. 0.46. Now it's negative, so I'm going to go over to negative 0.4, over to the 6th column. I think that's it. Did I get it? Yeah. All right, so negative 0.46, 3228. All right, so minus 0.3228. All right, so this number here is all of this. This number here is this part right in here. Let's do it. Okay, 14 minus 8 is 6. 5 minus 2 is 3. 8 minus 2 is 6. Is 6. Okay, so I think we've got it. There it is right there. So it's 0.6636. So about a 66% of all the data will be somewhere in that interval right there. Here's another example. Let's find the probability that Z lies in this interval between 0.81 and 1.94. They're positive, so 0.81, 1.94, and we're asking what's the likelihood, what percentage of Z's will land in this interval right here. We can get that measure by measuring that area right there. All right, so I'm going to claim that we're going to get this by getting all of this from here all the way up here and then subtracting this part right here. So let's do this. Let's go up to 1.94. So 1.9 over to the 4 columns, 0, 1, 2, 3, 4. Looks like 9738. So this is going to be 0.9738. But remember that 9738, that's really all of this, right? From here all the way out. So subtract off what we don't want, and that goes up to 0.81, right? So find the 81. Okay, so where is that 0.81? 0.81, 0.8, right there. There's 0, there's 1, 0.81, 7910. So minus 0.7910. 8 minus 0 is 8, 3 minus 1 is 2. Borrow, so what do we get here? 17 minus 9 and a 1. So I've got it there. So I'm going to say that this is 0.1828. So it's about 18%. About 18% of the data will lie in that interval. Let's do two more. Let's do this one here first. What's the probability that Z takes on a value less than, to the left of, 0.6, negative 0.6. All right, here's negative 0.6. What's the probability that we choose a randomly value of Z and get it down here? All right, well, we can do that. We'll just measure this region right there, and that happens to be exactly how the table reads, right? The table reads from negative infinity right up to our value. Our value is 0.6, so all we have to do, now really, it's negative 0.60, right? So just follow it up to 0.6 in the 0 column. Where is it? Negative 0.6 in the 0 column. 2743. All right, so that area is 0.2743. So we'll claim that this is 0.2743. So about 3% of the time Z will be down there. All right, so one last problem. I think we've taken care of every possible type that you could get here. All right, so now what's the probability that Z is less than, to the left of, negative 1.44? All right, so here's negative 1.44 down here. So we want to know what's the probability Z lands down there. Okay, that's going to be measured by that area. Or, now this is going to be a plus, or what's the probability that Z is to the right greater than 2.05? Now 2.05, that's out here to the right, okay? That's out here. 2.05. What's the probability we land out there? Okay, that's going to be this area right here. Now this area over here we can get directly, right? Because it's just how the table reads, from negative infinity up to our number. So this one I can read by looking at negative 1.44. So negative 1.4 right there over to the 4 column. Be careful, it's 0, 1, 2, 3, 4. I get 0.0749. So this area here is 0.0749. Now we need to get this area. Now the table, you know how the table reads. The table reads from negative infinity all the way out here. Well, that's the opposite of what we want. So we're going to have to take what? 1, right? What's the area altogether? 1. And subtract off what we don't want, right? The whole thing is 1. Subtract off what you don't want. That leaves us with this. So this area right here is going to be 1 minus, now, look up 2.05. 2.0 over to the 5 column. 0, 1, 2, 3, 4, 5. 9798. 9798. That turns out to be 0.0202. All right, so now we've got that area. I've got this area here, and I've got this area here, and I'm on an OR. So we're going to add these together. So we are going to get, I'll do it right over here, it's going to be 0.0749 plus 0.0202. So what do we get? 11,590. So I'm seeing this as 0.0951. Pretty small probability.